You know, for the last couple of weeks, we've been showing you science is often a mystery that takes detective work to uncover.
Well, today, COSI Science Detective Joe Blankenship shatters any notion that science is serious stuff. Let's head out to the Brainstorm Center.
Hey there, science detectives. Today we're going to talk about cold and how it can affect both living and non-living things. We're also going to talk about the states of matter, specifically liquids and gases. Now to get started, what we have here with us today is a couple of pop bottles. We've also got some roses, and we'll come to those later. But the star of our show today is one of my favorite things of all time. Folks, here it is. Liquid nitrogen. Now, nitrogen is usually a gas, takes up about 78% of the air we breathe, the vast majority. In order for it to be brought down to a liquid, it has to be cooled way down to 320 degrees below 0 Fahrenheit. If you've ever taken a bottle of pop and shaken it up real good, you'll notice that when you take the cap off, it explodes. Well, check it out. This bottle is specifically designed to hold in all of those bubbles and all of that fizz. That's why it doesn't spurt out everywhere until you take the cap off. When we put the nitrogen inside, you can tell right now that it's boiling. It's going very quickly from its liquid to its gaseous state, and it is expanding well past 800 times the size of its liquid state. We're going to see what happens when the pressure builds up. Here we go. Wow, that's what we call energy conversion. Pressure building up, pressure being released. Now let's see what happens when cold affects living things, like these roses here. Now I'm going to take one of these roses, and we're going to see what happens when frost, these frozen water vapors, actually apply themselves to living things. Of course, the liquid nitrogen is going to help us do it a lot faster. Now the cells inside living things actually swell up and burst when hit with very, very cold temperatures. We're going to replicate that here. All right, here we go. Smashing.
Unbelievable. What
Definitely
liquid nitrogen can do.
smashing. Now, for more on this experiment and one that you can try at home, obviously you can't try that one at home, you can become a science detective and log on to our website, wsyx6.com. That was pretty cool.
It was smashing. I really enjoyed watching that, but again, yeah, you can't try that at home because liquid nitrogen you just can't find. And we're not recommending anything.
You can't get your hands on, but I wonder what else he could dip in that and smash like that.
I can't wait till next Wednesday now.
All right.
Hey science detectives, you know one of the first things you see here when you come into COSI is the high wire unicycle. Every day folks just like you get lined up, get strapped in and go for a ride on this gravity-defying attraction. Some of you think it's one of the coolest things of all time. Others, however, aren't quite so sure. Some of you ask, what if I tip the thing over? What if I lose my balance? What if I fall? Well, I gotta tell you, the answer to all of these questions is, you don't have to worry about it. Just pedal. That's all there is to it. And it all has to do with your center of mass. Now, the high wire unicycle is 17 feet off the ground. The steel cable the unicycle rides on is 84 feet from end to end and is over 1.5 inches thick. Now, the unicycle itself only weighs about 25 pounds, and if it were just the unicycle and the wire, you'd have a challenging ride indeed. However, what's attached to the unicycle directly underneath is a 250-pound counterweight, which makes the ride completely and totally safe for just about everyone. The unicycle is virtually impossible to tip over, and it all has to do with gravity. See, if the rider leans to one side, the counterbalance goes up the opposite side. That's when gravity takes over and pulls the counterweight down, bringing the rider back up to the top. That's it for this week here at COSI. Now back to you.